Assalamualaikum and hello. My name is Muhammad Firdaus bin Abdul Razak, DE180128. This is for our task for assignment 1, which is we must use the HEB or perceptron and Adaline training algorithm to classify the A or B to solve the linear problem below with 100% accuracy. This is the table for the classification class A and class B. Now we go to the Excel. For the class A, we classify as a T equals to 1, and for the class B, we classify by 0. For the learning rate that we use is 0.5. Now for the herb training algorithm, this is the key point, which is random initial weight y equal to t, weight new equal to weight old plus learning rate times xi, which is x1 or x2 or x3 times y. For the bias new is equal to bias old plus learning rate times y. So this is the training table for the iteration 1. The x1, x2, x3 is a 0, 0, 0, which if we refer to the question, the t is 1, so y equals to 1, and then we proceed to 0, 1, 0 is y equal to 1, and 0, 0, 1 is y equals to 1, and for the 1, 1, 1 is equal to 0, which is this is for the class B section. 1, 1, 0 is equal to 0, and 1, 0, 1 is equal to 0 for the y. Now for the initial weight, we use a negative 2.5 for the weight 1, and weight 2 we use a 0, and for the weight 3 we use a 1, and for the bias we use a value of 1. So we just use this formula to calculate the inside is right here. For example, to get the iteration 1 is right here for the weight 1, which is weight new, the value is right here, is weight old plus learning rate times x1 times y. So when the x1 is a 0, so we just take the weight old, which is negative 2.5. It's same until the iteration 3, and for the iteration 4 we use this one too. For the weight new is right here, is a weight old is a negative 2.5, is right here, plus learning rate xi times y. For the y is a 0, so we just take the value of weight old. So it's same until iteration 6, and this formula we use to calculate the weight 2, weight 3 and a bias. The final value that we got is a weight 1 is negative 2.5, and weight 2 we got 0.5, and weight 3 we got 1.5, and bias we got 2.5. For the activation function, the theta is 2.5 because after we calculate the y new, to activate minimum, the function is 2.5, is right here. The calculation is negative 2.5, which is weight 1 plus weight 2 plus weight 3 plus bias equals to 2.5 activation function. So when the x1, x2, x3 is 0, so we just get the value of bias only. And for the 0, 1, 0 is we have the 0.5 right here, so 2.5 plus 0.5 we got 3, And for the 001 is 2.5 plus 1.5. We got 4 right here. And for the 111 is a negative 2.5 plus 0.5 plus 1.5 plus 2.5. And we got the 2 for the y new. And for the 110, we got 0.5. Based on the calculation, 2.5 minus 2.2 plus 0.5. And the last one is a 101, which is negative 2.5 plus 1.5 plus 2.5, and the y new is a 1.5. And this is the calculation to get the linear line for the Matlab calculation. And this is the unknown that we use. Each x1 is and x2 is the same, which is negative 9, negative 6, negative 3, 0, 3, 6, and 9. And the observation is on the x3 to know the value of x3. Now we go to the Matlab to see the graph, and we run the coding. Is Hebbian right here. We run at the path. This is the linear line that we've got for the proven. We just add right here. So we can see the dot right here is x is referred to the x1, y is referred to the x2, and z referred to the x3. Negative 9, negative 9, negative 12. And right here, negative 6, negative 6, negative 8, negative 3, negative 3, negative 4, 0, 0, 0, and we got the x3 is a 0, and 3, 3, 4, x1 6, x2 6, x3 is a 8, and the last one is 9, 9, and 12. So it proven by the linear line. If you can see, it's a straight line right here. Now we go to the retrain section to see the training. If we change the truth table like randomly. Now for the retrain, we just switching the A B A B A B, and before this we just use as a first, we classify by A first and then B. So at this time we retrain, we switching is A B A B A B. So this is the table that we got, and the final answer that we get is a negative 2.5 for the weight 1, and for the weight 2 is 0.5, and the weight 3 is a 1.5, and for the bias we got 2.5, and this value is the same with the train value, is right here, it's the same. And for the activation function, it's still the same, because after we calculate from here, we still got the same value for the activation function. And for the calculation to get the x3 is still the same before. And how to find the x3, the value of x3 is still the same. So the retrain graph is the same with the herb algorithm training before. It's the same with before. Now we go to the my friend to share about the Adaline training algorithm.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azfar. My metric number is DE180137. So I will proceed to Adaline, which is Adaline training algorithm. So we have been provided a few formula, which is weight new and bias new. So weight new is equals to weight old plus by and the number of learning rate, and then the number of x times by t minus by summations for bias new, bias old plus by the learning rate times by the t minus summation. So in this project we have been provided a truth table. So in this truth table we have three input, which is s1, s2, s3, and then we have been provided also the number of t, and then the class of truth table, which is a and b. So okay, we proceed to the iteration. So in this project, we need to calculate the iteration, which is the number of s1, s2, s3, and summation, the number of t, the t minus by summation, w1, w2, w3, and bias. So w1, w3, w2, and w3 is the random number initial. So we have decided to use. So the number is for w1 is -3, w2 is 0, and w3 is 1. So the bias number also the 1. Okay, before we calculate it for iteration number 1, so we have to put the input x1 until x3, and then the number of t. So for the x1, x2, x3 is 0, 0, 0, and then t we got from the truth table, which is 1. So to calculate the w1, so we use the formula, which is wn equals to weight old plus by n times by the number of x, and then t minus by summations. So same goes to bias, which is bias new. So bias new is equal to bias old plus by learning rate times by t minus by summation. So we calculate w1 first, which is w old is -3 plus by number of n, which is learning rate 0.5, times by x number x1, which is 0, times by t minus summation, which is 0. So t minus summation is based on t minus by 1 minus by 1, which is we got 0. So for w2, same also, w2 is 0, weight old is 0 plus by 0.5, and then times by 0, and then times by same also 0. So we got the number is 0. So for w3, so w old is 1 plus by n is 0.5 times by 0, then times by also 0. So we got the number of w3 is 1. So for the bias, we use formula bias old plus n times by t minus summation. So for b old is 1 times plus by 0.5 times by 0. So we got it, the value of bias is 1. So okay, we proceed to the iteration number 2. So the input number is based on truth table, which is 0, 1, 0, the number input of x1, x2, and x3. So how to calculate w1? So w1 we got it from based on formula. So w all also -3, so plus by the number of learning rate times by the number of x1, 0, then times by the t minus summation, which is 0. So after we calculate, we get the number of -3. So for the w2, we calculate w all, which is 0 plus by the number of n, 0.5 times by x2, which is 1, and then times by 0, which is t minus summation. So after we calculate, we get the number of 0. So So for weight 3, we calculate weight old is 1, and then plus by 0.5 times by 0, and then times by t minus summation, which is 0. So after we calculate, we get the number is 1. So for bias also same, we use the previous formula, which is BO, which is 1 plus by 0.5 times by 0. So after we calculate, we get the number is 1. So the formula will use until iteration number 6. So after we calculate, we get the final value is W1 is negative 2.5, and then W2 is 0.75, and then W3 is 125, and then the bias number is 1. So this value we'll use in activation function for the next calculations. Okay, we proceed to activation function. So we need the data from iteration number 6 to accomplish the final value of y prime. So here we go, we start with the first row, which is x1 0 times by w1 negative 2.5 plus by x2 0 times by 0.75 plus by x3 0 times by w3 1.25, and then plus 1. Then the final value is 1 for y prime. So for the second row, we use the same method also. So x1 is 0 times by negative 2.5, x2 1 times by 0.75, x3 0 times by 1.25 plus 1, and then we get the final value of y prime is 1.75. To get the final value of negative 0.25, we use the same method to get the final value of y prime. So this will present from summation of this, and then the value of 1 will be equal or higher for activation function. So if it's 0, it will be lower than the value of activation function. Okay, after we calculate, we get the final value of activation function, which is 0.75, and then we proceed to the table over here. So how to get the final to get the value of x1 and x2. So x1 and x2 is based on the formula over here, and then how to get the x3. So x3 we derive it from the formula here, and then we get the formula is 2x1 and minus by 0.6 times by x2 minus by 0.2. So how to get an x3? We need to put the value from the x1 and x2 inside this formula, and then we get the final value of x3. So for the first answer is negative 12.8, then negative 8.6, then negative 4.4, negative 0.2, and then 4, 8.2, and lastly is 12.4. So the result is same, goes to Matlab. So we open the Matlab first. So the value over here is x1 will be present as x, and then x2 will be present as y, and then lastly is z will be present as the x3. So over here you can see the graph is linear. So negative 9, negative 9, negative 12.8, and then negative 6, negative 6, negative 8.6, same like the table. So x1 is negative 3, x2 is negative 3, and then negative 4.4, and 0. You can see the answer is same. So okay, after we calculate, we get the final value for activation function is 0.75.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ferdaus bin Ahmad Rofi, and my metric number is DE180094 So I am going to continue the presentation with Adaline training algorithm retrain. So in order to do the retrain, we decided to alternate the class. So first of all, we have 000 T1 class A, and then 111 T0 class B, 010 T1 class A, 110 T0 class B, 001 T1 class A, and 101 T0 class B. So we change the data from to this. So after that, we go to the table for W1, W2, and W3 and bias. This is the random initial number that we decided to use, which are -3, 0, 1, and 1. After that, we put the data from this table into this table. So 000, 111, and so on. And the T here, we also follow the data from here. So after that, we calculate the sum. So the sum 000 plus 1 equal 1. So 3 minus sum, T minus sum, 1 minus 1 equals 0. So for the 0 value here, we just follow the value before it. And then for the bias, we calculate it. This is the formula. So the BO is 1 plus N T minus E, because T minus E is 0. So B new equal to B0. So 1 also. So the next iteration 2, we have x1 1, x2 1, x3 1. So the sum is -3 plus 1 plus 1 equal -1. So T minus -1 equal to 1. So we have to calculate the value because it has a 1. So this is the formula. W new equal to W old, -2.5 plus N. Our learning rate is 0.5. X1 is 1. T minus sum equal to 1. So we get -2.5. So the next W2, the old value is 0 plus N negative 0.5, x1 1, T minus sum 1, and then we got 0.5. For W3, W old is 1 plus 0.5 multiplied with 1, T minus sum is equal to 1. So we got 1.5. Next is the bias. For the bias, this is the formula. B old equal to 1 plus N 0.5 plus 1. So we got 1.5. So the same method goes for iteration 3, 4, and 5, and 6. So after we have done the iteration, we need to find the activation function. So the value that we are going to use is for W1 -1.75, W2 0, W3 1.5, and the bias is 1. So to find the activation function, x1 0 will be multiplied with negative 1.75 plus x2 0 multiplied with 0 plus x3 0 multiplied with 1.5 plus with 1. So we get the y prime 1. Next, x1 1 multiplied with negative 1.75 plus x2 1 multiplied with 0 plus x3 1 multiplied with 1.5 plus 1 bias equal to 0.75. So the T1 represent that the summation of this will be equal or higher to the activation function. So if it is 0, it will be lower than the value of activation function. So to get the next y prime, it follows the same step as I have said before. So after we have calculated the table for finding the activation function, we have discovered that it is between 0.75 and 1. So we add up 1 plus 0.75 and divide by 2. So we get the value of 0.875. So activation function value is 0.875. So this step we use to get the graph. So for x3, to find x3, x1 will be multiplied with 1.75 plus x2 0 plus x3 1.5 plus 1, and then we rearrange it back and it will get 7 over 6 x1 minus 1 over 12. So this is the equation that we got to find the linear line, and in this table it shows that the value of x1, the unknown we use to get the linear line, x3. So x1 negative 1, 9, negative 6, negative 3, 0, 3, 6, 9. So this is the graph that we got from Matlab, and I want to show you. So here x represent x1 and z represent x3. Y represent y x2 exists. So as you can see, it is linear. So to compare the value for Adaline training algorithm that we have retrained it, the activation function is 0.875. But for the original one, the activation function is 0.75. And we can see here the value for x3 is almost the same with the x3 that we got when we retrained the data. And from the graph, the pattern is almost the same. So that's all from us. Thank you.